Hello, everybody. We'll jump in here. We'll start the presentation here. Hopefully, you're here to talk about how to debug your cluster when it's on fire. If not, sorry. It's an interesting talk. You should stick around, though. OK, to start us off, I want to say my name is Tyler Yahn. I work at Splunk as a software engineer. I'm also an OpenTelemetry maintainer. I work a lot in the OpenTelemetry project, as my co-presenter Mario can show. I do want to introduce Mario, but I do want to also call out that Nikola was supposed to be here. Nikola, if you're watching, we miss you. Didn't make the flight, unfortunately. So yeah, all the errors are ours, and all the benefit is his. So just a heads up on that. But yes, also I've got with me Mario. It's definitely a very close second best. Yeah. Go ahead, Mario.
Yeah. Hello. Hello, I'm Mario Macias, principal engineer from Grafana Lab. I've been also working in the OpenTelemetry eBPF instrumenter project, and I'll do the presentation on behalf of my colleague Nikola.
I will also call out that Mario is one of the founding contributors to the project we're demoing here, so he doesn't give himself enough credit. But OK, moving on. To start us off, I want to set the stage, and I'm maybe just ask this question and just explain it a little bit. Who in the audience here is running a production system and gets a page at 3 a.m. That things are not going well? OK, you're definitely in the right talk then. OK, yeah. So explaining to you is, I don't have to say the sheer panic that comes when you're in a system. Maybe it's got multiple services you're not familiar with. It's maybe your second day on the job. You don't want to take production down. You log in and you have no idea, right? Like that's when the sweat starts trickling down your neck at that point, right? You definitely are seeing things maybe like databases are throwing errors, maybe just red everywhere, right? Definitely a lot of issues, right? But at the end of the day, the main thing is that the users are having a bad time, right? Like this is actually your problem you're trying to solve, and you care a lot about it. That's why you're so stressed out. So how are you going to fix it? Well, we know it needs to get done fast. It needs to get done now, and it needs to get done as soon as possible. You need to do it in a way where it doesn't make things worse, right? There's never a situation where it's bad enough you can't make it worse. So let's try to only improve things, not make things even worse. It may be that since you're in a new system, you actually have limited visibility. There's a good chance that maybe your company is in an early stage of observability. If you've been doing this for a while, you've definitely lived through this already where you didn't actually have any idea what was going on in your system. So yeah, stress level maximum at this point.
So yeah, we are going to talk.
Can you hear Mario by chance?
We are going to talk about the traditional observability dilemma. This is adding observability to your system requires usually changing the code, or even if you have SDKs that perform automatic instrumentation, it requires reconfiguring your application, testing that everything works. Once you have reconfigured, you need to redeploy and restart your services. This is something that I will avoid during, This is something that I will avoid during an incident. Anybody will avoid if possible. Restarting services, deploy changes you don't know how they will affect. Because you have limited visibility into the system interactions, and also during an incident, time is running out, and more than ever, time is money. So we are like stuck in a catch-22. This is an example of how adding observability to your applications will work in a traditional manner. So for every of your services interacting, you will need to add or reconfigure, test that it's working, or fix anything you did wrong, review the instrumentation, then build and run, redeploy, do it again for all your services. This is fine if you have time and you have a instrumentation strategy to implement in your application, but maybe during your incident, if you haven't finished this process, you don't have that time. So ideally, the letter to Santa will be, I deploy something, this something auto-discovers all my services and start emitting traces and metrics to a collector, metrics and traces collector. So immediately I can start identifying the root cause. So we want to go from days for instrumentation to minutes.
Okay, and so how are we going to get there, right? We know we want to solve this user problem. We want production to come back up. How are we going to actually get past this traditional observability issue? So to start, has anybody here heard of OpenTelemetry? Okay, so everybody. So yeah, I don't need to tell you too much. It's a pretty awesome project. Obviously, I may be involved, and I'm favorable with a biased opinion. But yeah, it's a great project. Offers vendor-agnostic APIs and SDKs and utilities. Doesn't incur any lock-in. The industry is obviously, as you can see from the room, backing this. I think that this is something that you get a lot of support for. So this is the way we want to actually use some sort of solution that would provide this as observability going forward, right? The problem is that traditionally, OpenTelemetry, for a lot of languages, not all, obviously there's some auto-instrumentation in here, but for a lot of languages, requires code changes. It has that traditional observability dilemma that Mario was just walking us through, right? So can we get around that? Okay, maybe this is the last question I ask. I ask a lot of questions. How many people have heard of eBPF before? Okay, great. This is awesome. So this is the other special sauce. Like, this is like the magic that's coming along here. This is a new thing that is not new at all. It's extremely old. It's just becoming very popular in trying to solve problems. So it's a kernel level set of instrumentation that we were able to use here. It doesn't require any application changes, meaning that your code, if you're running an opaque binary, is just an opaque binary, and it keeps being that way. It's high performance, low overhead. It's safe and secure by design. And it has a lot of visibility throughout the entire system it's running on. In fact, it has pretty much the ultimate visibility of the system it's running on, which is phenomenal, right? So why is this useful for us when we're looking at incidents and running things in production, right? The important thing to keep in mind is that it's safe for these sort of situations because of its sandbox nature. All eBPF programs themselves are run in a sandbox that is not able to actually interact with the resources directly outside of its sandbox. It needs elevated permissions. If you wanted to give that, you can do that, and it's entirely configurable that way. The thing that you don't have to configure is the comprehensive view that it actually sees into your system. You don't have to tell it that this is running here, this is running here. It just knows. It's instantly able to see this, and it's quick. It's incredibly fast. So, okay, now we have these two utilities and these two tools. With that, we want to talk to you about what we're calling OBI. OBI we're introducing here today is OpenTelemetry BPF or eBPF instrumentation. This is a new project that was just recently donated to the OpenTelemetry space. And what it is doing is it automatically discovers all of your services using these eBPF technologies. It generates distributed traces using OpenTelemetry, this OpenTelemetry standard, so you have all of this backing across the entire industry. From this, you're able to create service topology maps, do amazing network level insights, investigations into this. All of this, again, without zero configuration. This is leveraging that eBPF technology here. It's fast as any sort of eBPF program is, right? So we can deploy this extremely quickly. We'll show you in a little bit how quickly that actually means. One of the key things, again, no restarts. You're in the middle of a production incident. You don't want to restart something and have a continual spiral of things just not restarting at that point because you've overloaded the system again. It's language agnostic. It's sitting on the kernel. Like, it doesn't actually care what you wrote this thing in. And what we've decided to do is look at things in a way that doesn't require any sort of investigation internal to that binary. It's production safe and open source, which we'll talk a lot about. Okay. Enough talk. Let's see what it actually does, right? Let's recreate a little demo, and we can jump through this. In this, we're trying to do something that's very familiar. We have multiple services here, in particular 4 core microservices. It's the Istio book sample demo, or book info sample demo, if you have already seen it. It's running 4 different programming languages, most of which I'm not familiar with. I'm guessing there's polyglots in this audience who are laughing at me at this point, but yes. It's something that maybe like I don't have familiarity with these things, and let's see if we can actually go ahead and troubleshoot. Yeah. So obviously it's got some simple problems in it. To look at this, we're going to use some open source tooling. The observability stack here in particular is the Grafana LGTM stack. Nothing unique about this. Again, OpenTelemetry allows you to take your data anywhere you want to go. Any other open source backend, any other vendor, it allows you to go there. So yeah, enough talk. Let's jump into it. Oh, you all set? Okay.
I think no. Can you hear me well? No. Okay. Yeah, if you can just put the mic.
I'm the highest paid mic stand.
Oh, sorry. Let me one moment. Choose content, mirror entire screen. Okay. Okay, so I have this Istio demo with some added extra problems that you can see it's failing. It's someone called you at 3 a.m. Hey, this application is failing, is giving errors, fetching products. We are not selling anything. We are losing money. So let's fix it. I don't have visibility at all. So here you can see I have a Grafana stack. Okay, I have a local Grafana. If I go here, I don't see anything. So anything is instrumented. I will deploy OBI. First of all, here is my Kubernetes cluster with some pods. We are seeing a pod, MySQL pod, that is crashing. I don't know. Okay, if you look the logs, it seems that there is something misconfigured, is making it to crash. So if we didn't have instrumentation, we might be tempted to say, oh, this is the root cause. Let's fix it directly. Of course, this is something it needs to be fixed, but might not be the real cause. So let's provide more instrumentation than just the pod information or the logs information. For that, I'm going to deploy OBI. To provide OBI, I need to configure it with some data, like, for example, I need to provide some endpoints to export my metrics and my traces, and I need to tell OBI to discover or to provide some information about what I want to discover. In this discovery section, this is a regular expression, so adding a point here, I'm telling OBI, discover everything. So it will instrument all the services, excepting those Kubernetes services or other related hotel collectors that will add noise. So it automatically ignores them. So to deploy it, I can just use Helm install. We released a Helm chart, OpenTelemetry eBPF instrumentation. So it is here. In few seconds, we will start seeing data here.
What I'm just seeing was that was less than the 30 seconds we advertised, right? Like we're fully deployed and we're up and running. Can we maybe take a look at some Kubernetes images and see if we're verifying?
Yes. Yes, let's see, for example, this pod. This pod has been created now. Let me increase a bit the size of the font. This is MyOB OpenTelemetry eBPF instrumentation. If we come here and go to the logs, you will see here there is a lot of noise. Those are just debug messages I added just to check before anything that it is getting information. If I stop this, you can see this, like it detects an HTTP client doing a post to this URL, return code 200. Since I configured it to instrument everything, I even get DNS. We even get DNS instrumentation with the results. So I think it passed, and it happened in all time. So if we come here, we see a service graph with all the instrumented resources. We see that many, all the instrumented services, we see that many of them have a high error of high rate of errors. Yeah.
Just to ask you a question here, Mario. Like all we did was we deployed one binary we see in our entire cluster. Are any of these services instrumented outside of OB?
None of those services are instrumented outside OBI. All the data you see here, all the metrics and traces are provided by OBI. Also the connections between the services. Yeah. Let's investigate a bit. We can see that there is this product page endpoint having a large duration. It's taking too long time. Probably it's causing some timeouts. Here we see how the metrics are being created and how it provides some exemplars to that metrics that might show some insights about the delay. Okay, this is, it will require a bit of few seconds more to get all the distributed tracing.
It's a live demo.
Yeah, it's a live demo, you know. Let me choose another exemplar. We can choose another exemplar like this that looks older. Okay, we get another. It might take, you know, this is a local instance in a virtualized container, so might be a bit slow internally because it's receiving a lot of data. But okay, let's go here and okay, this is the good one. We need to be patient, even if we are in a hurry. Sometimes you need an extra minute. Here we see all the distributed trace of our services and how they interact. We might see even a bit of noise because we are even instrumenting DNS. So here you might be a lot of DNS failures because it is looking for multiple options, but it eventually gets the URL. We can see some failing parts here. For example, this product page. Once it gets the IP, it submits a request to an external host. In that case, it submits a request to a Google API. Since OBI is instrumenting the DNS, it's able to it is able to infer which IP belongs to which external host name. So as an example here, we can see like it is returning a 429 error. This URL, so we see this URL is returning a 429 error. So it is being rate limited.
So I got a question for you, Mario.
Yeah.
Though, like this is phenomenal. Is that our problem? Is that the thing that's causing our users some expectation or some sort of error? I also noticed you weren't talking about the database anymore. Like, where's the database in all of this?
Yeah, it seems we are not reaching it. OBI is able to instrument databases. It seems we are not reaching it. We are getting those rate limits and even some errors. Here you see this product page is returning a 499. That means client disconnected because of the long time we are having in this, for example, these reviews V1.
I see. So what you're saying is that because OB was able to give us cluster-wide visibility into this system, we're able to not only find the error that's causing high latency at this point, but a host of other errors that may have been red herrings if we didn't have this observability?
Yes.
Yeah, that's fantastic.
Yes.
Yeah.
Yes, this, I need to increase a bit some of those services that are having a range of errors, we are running multiple versions. So in that case, for example, you see these ratings V2. In that case, I will migrate or I will reconfigure my service to migrate to, for example, from ratings V2, which is failing, to ratings V1 are different versions of the same server, so someone may be rolled out progressively. We now can see that the V2 version is failing, but the V1 is working properly. So here we can see traces that are successful. In this example, what we could do is just reconfigure our deployment to keep staying with the ratings V1 version of the service.
Wow, okay, so we went from maybe chasing down a database and wasting an hour of our time to finding an actual plan within 5 minutes where we can fix the user problem, roll this back, go back to sleep, and then tomorrow look into all these other errors?
Yes.
Phenomenal.
Yes.
Yeah, that's great. Yeah, cool. Okay, yeah, definitely. I guarantee everyone who clapped has lost at least 6 hours of their life to this, yes. Yeah, I've been there as well. Yeah, believe it or not, I'm 18 years old. No. Cool. All right, so let's really nail this down. Like, what did we just accomplish here, right? 30 seconds, we had a deployment. 10 seconds later, we're looking at our first trace, right? Like, none of that traditional stuff. Like, we were really fast in actually getting things out. 0 code changes. I didn't show you any of that code that we were running, right? I know there's a service, I can show you an endpoint, but like, none of this was actually doing anything with the code that's underlying this, right? And yet, we were still able to see the flow of distributed context through each one of those services, right? Like, this is really, really powerful stuff, as well as the full breadth of the network that it lives in. Yeah, 5 minutes with some nice banter here, obviously, and we still found a root cause, right? Like, that's invaluable at 3 a.m. That's invaluable, like, in the middle of the day, right? Like, MTTR is important, and this is enabling faster MTTR, right? Okay, so if we think about it from a high-level perspective, what are some of these things that we're actually changing, right? This world that we used to live in where things were wrong, and that's all we could say. Like, we would just, you know, throw your hands up, start looking at logs, maybe log into the system, do some kubectl, like, let's find it, right? Turned into, no, now we have a targeted thing. We know the rating service is having some sort of issue, and we can fix it by moving traffic, right? We all know how to do these sort of things. Hours of investigation have turned into 5 minutes of just troubleshooting with a root cause analysis. There's nothing blind about it. All that stress and guesswork is now a confidence in our solution. We have clear metrics to show what actually needs to be done to change. And we're not fighting fires, we're proactively fixing things tomorrow as well that could eventually blow up. So if we look at it just by the numbers, right? 5 to 7 days, 5 minutes now. Traditional instrumentation of trying to fix this thing in a way that would give us the similar visibility, give us the similar ability to actually restart this service in a way that could actually show what we just looked through. That's pretty incredible. Obviously, there's some, like, you know, vanity metrics here, but if you think about it just in the amount of engineering hours you're talking here, we were talking maybe 1 to 2 engineers, 5 days. That's, you know, thousands, maybe tens of thousands of dollars in engineering hours, instead of, I don't know, dozens of SRE hour or minutes in trying to actually fix this. Like, there's actual, like, money value here at this point, right? Every minute that we are saving during an incident, that's a production a win for us, and our customers are going to be happy for it.
Okay, so what do you need to run that? You need a Linux kernel, at least version 5.8. That means any Linux kernel younger than 5 years should work. Even if you have a Red Hat 8 or CentOS 8, which has kernel 4.18, this kernel from Red Hat backports all the eBPF patches to that kernel, so it will work also in CentOS or Red Hat 8. And you need an Intel or ARM architecture of 64 bits, which are, I would say, 99.9% of the server of the servers in production. This runs in all the major cloud providers: Amazon, Google, Azure, DigitalOcean, but any cloud provider giving you the opportunity or giving you the chance to install a modern Linux kernel with eBPF installed, it should work. What is OB observing? We can observe web traffic, that is HTTP, REST APIs, gRPC. It is also observing databases, different protocols like Postgres, MySQL, MongoDB, Redis, and message queues like Kafka. And this is growing. We are working, adding more and more protocols. What doesn't support are custom spans. So we are providing a generic instrumentation for your services, but of course, OB cannot know your internal business logic. The good part is that it understands if you manually instrument, you take the OpenTelemetry SDK, add it to your, for example, your Go program and start adding manual spans there, even if you haven't configured the full SDK to export the data, OB will instrument those custom spans, so you don't need to choose between OBI and the SDK. You can get both because even you can progressively instrument your application using the SDK, and it will keep coexisting with OBI.
Cool. All right, and with that, we'll try to wrap it up here because we are. I think that was a 5. It's tough to see from this far. But I'd like a few things from you. Go ahead and try this demo. I would really want you to go ahead and see the power of this. Like, you will be up and running and looking at these root cause analysis just the same way we were, 10 minutes. That's, and if not, you can find my GitHub handle and give me all kinds of horrible messages afterwards. If you want to see more about the docs, there's a link here for that as well. For some additional help, any additional questions we aren't able to answer today or in the future, you come up with some new ones, find us on Slack. We're on the CNCF Slack under the OTel eBPF instrumentation. Very active right now, so definitely a good place to get some help. If you want to get involved from a contributor's perspective, please do so. We would love the help. You can find the repository here. It's a great way to find issues, find the code itself if you want to review it. Welcome to open source. And yeah, if you want to build it or add your contributions. Also, come find us at our SIG meetings we hold every week, Wednesday at 8 a.m. Pacific time or 11 a.m. Eastern time or horrible European times, which Mario is happy to make. Yeah. But yeah, with that, we'll say thank you. And I think we might have some time for some questions, but yeah. Ask them to go to the mic.
Okay. I think for questions, you have to go to the microphone.
Yeah, please go up to the mic, and we can answer some questions.
Great session, guys. What is the recommendation from OpenTelemetry? To use the OpenTelemetry injector or OV or any other? It is also zero code, that's why I'm asking.
Sorry, because there is some echo and I couldn't understand your question. But
So there was another session about the OpenTelemetry injector that inject the OpenTelemetry agent libraries automatically without any code changes. What is the recommendation from the OpenTelemetry ecosystem?
Yeah, that's a great question. I'm happy to take this one. So I definitely think that if you are interested in the injector, it's a fantastic technology. If you're looking at something that's looking for 0 restarts and you're using the eBPF technology, low overhead, maybe a sandbox environment, that's I think where OB really shines. The comprehensive nature, you don't need to look on a system. It's not application based. It's across the entire infrastructure. Anything that's running on that system is going to be detected by OB. If you were looking for the injector to use the OpenTelemetry auto instrumentation automatically, use that. Like that's a fantastic service. If you didn't watch the talk, it's worth going back to that one by the people that have produced it. But yeah, great question. Thanks.
Can it follow traces across multiple clusters or non-Kubernetes-based infrastructure?
Yes. That's a question, if I got you right, clusters that aren't on Kubernetes, right? Yeah, absolutely. So what we've shown you is what we expect is the common case using Kubernetes, but this is a eBPF program that you can run, which is just a binary, and so you can compile it to many different operating systems, and you can run it on standalone bare metal on whatever orchestration system that you actually want to use. Yeah, it should work in all of those situations. Yeah.
Yeah.
Sorry, I have multiple questions on this. So how does it monitor all the applications that are running on the cluster? So this is just one single service that you deploy, correct?
Yes, it runs, as Damon said, it's a single process on each node.
On each node, it runs as a daemon set basically.
Yeah.
Okay, cool. So let's say if an application that is deployed in cluster 1 calls another application in cluster 2. Okay, I'm just giving an example. So if we have this OBI OTL collector installed on both the clusters, will it be able to find the node graph that you showed us?
It will depend, for example, if in the middle it has some, it can depend, and the connection might not be discovered if there is some ingress that messes up a bit, but usually you can get also the external traffic as we saw before with this Google stuff, but yeah, you can get it.
Just to add to that, the context that we're passing across this is not like read and sent by OBI. It's sent on the wire. The payload itself can change trace context. We are actually making sure that your communication is complying with the W3C trace context standard, and that context, as long as it's not, as Mario is pointing out, stripped by something else in between those two things, it'll seem like it was instrumented with OpenTelemetry natively as it goes across the wire.
Yeah.
Okay.
Yeah.
Okay.
Definitely come up afterwards. We can talk more as well.
Yeah.
Okay. And the Grafana dashboard that you showed, right, with the node graph, that's like a preset or a default one?
I'm sorry, I didn't understand that one.
So the Grafana dashboard that you showed, right, that showed the traffic from the application A to application B, right? Do you have a default dashboard for that, which we can use?
This is just the metrics explorer. It's neither you come here to explore tempo service graph and you get it by default.
Oh yeah, this is all the open source offering of the tempo. Yeah.
Yeah. This is part of the open source offering.
Okay, thank you.
Okay, I think we're all out of time. Yeah, definitely out of time. I see a lot more questions. Come find us afterwards. Happy to answer them.
Yeah.
Yeah, thank you everyone.